Yo, it's me again, your boy Jazzy, and I'm back.
I'm sure nobody missed you.
Wait.
Welcome back to OpenSec Maths. It's me, Abby.
Today will be our third and final video on the topic of matrices solving simultaneous equation.
Remember that system of simultaneous equations we spoke about in the first matrices video, the one with the siblings with the eating problem?
Well, these systems of linear equations are also called simultaneous equations because we are solving for more than one variable, x and y. Simultaneous equations can be solved using elimination method, as we learned substitution method, but today we're going to learn how to use the matrix method. The first step is to convert these two simultaneous equations into its matrix form. Abby?
The matrix form of a system of simultaneous equation uses the formula A multiplied by x is equal to y. That is, matrix A multiplied by matrix x is equal to matrix y.
Matrix A is made up of all the coefficients of the linear equations. I hope you remember what coefficients were, right? That would be the number before the letters. You write them just as they appear in the equation. In the top line, you put 2 and 3, and in the bottom line, you put 4 and 1. Notice how the x's line up with the x's and the y's line up with the y's.
Matrix X is the variable matrix. The linear equation has two variables, so we put them in the variable matrix in the order they appear, x on top and y below.
And finally, matrix Y is the resultant or the answer matrix. We put the results or the answers of the simultaneous equations in the matrix. So that would be 23 and 21. Now we've successfully converted the system of simultaneous equations into its matrix form. Now what I want to know is, how does this help us at all?
Well, remember our goal in solving simultaneous equations is to find the value of x and y, or whatever variables are used in the equation. If you go back to our video on solving linear equations, we did this by isolating the variable on one side of the equal sign.
However, in this pair of simultaneous equations, the equations have more than one variable, so it would not be possible to isolate them on one side in the same way. So instead, we use the matrix method.
That's correct. And as you can see in our matrices equation, all the variables in the equation have been isolated in the matrix X. So essentially, all we have to do to find the value of two variables in the simultaneous equation is to solve for the variables in the matrix X by isolating that matrix on one side of the equation. That leaves us with the equation matrix X, which is the variable matrix, is equal to the inverse of matrix A, the coefficient matrix, multiplied by matrix Y, the answer matrix.
Wait. How we jump all the way there? Let's walk it through so I can understand what exactly is happening, because this always gets me a bit panicky.
Yes, but remember, don't panic, it's just maths. First, recall our lessons on solving linear equations.
So that means if A is multiplied by x is equal to y, we solve for x by isolating x on this side of the equation.
That's right, and we do this by eliminating A.
Now, if I remember correctly from our video on linear equations, because the equation says A multiplied by x, we eliminate A by doing the reverse operation, which is division. So we divide ax by A, but how do we do that with matrices? We learned how to add, subtract, and multiply, not how to divide.
Well, we did not learn how to divide per se, but we did learn how to find the inverse of a matrix. And we did that because a matrix multiplied by its inverse is always equal to 1.
So matrix A multiplied by the inverse of matrix A is equal to 1?
Yes.
So if we write it out, it would look like this. A multiplied by A inverse is equal to 1, which can be shortened to A times A inverse is equal to 1.
That's correct. So going back to our original matrix equation, if we are to eliminate A, all we do is multiply A by its inverse, which will give us 1, which would leave us with 1 by x, which is equal to x. Now we have our matrix X isolated like we wanted.
But remember, whatever we do on one side of the equation must be performed on the other side of the equation as to keep the scales balanced. Since we multiplied ax by A inverse on this side, we must multiply y by A inverse as well.
And this is how we solve for x, which is the matrix that contains all our variables in the pair of simultaneous equations.
It's all coming together now. It's all coming together. So to solve this equation, we first need to find the value of A inverse. And if we recall from our last video, we do this using the equation A inverse is equal to 1 over the determinant A multiplied by the adjoint A. This looks like plenty. And it's plenty. But we can do it. We can do it. Let me go.
Alright, the determinant is found by multiplying the difference between the product of the diagonal from left to right and the product of the diagonal from right to left.
That would be 2 multiplied by 1, take away 3 multiplied by 4, which is 2 take away 12, which is negative 10. So we have found the determinant. Now to find the adjoint.
And that is found by switching the positions of the numbers going diagonally from left to right and changing the signs of the remaining numbers to their opposite signs. That gives us 1, negative 3, negative 4, and 2. So now our equation looks like this.
Now you can solve this equation by multiplying 1 over negative 10, that's a fraction, by the adjoint, and then multiplying by y. But because it's a fraction, that could complicate the equation later on. So instead, multiply the matrices first, as they only contain whole numbers, and save the fraction scalar multiplication for last.
Very smart advice there.
Yes.
Jazzy, I am proud
Give me a
of
little
you.
clap now, give me a little clap now. Thank you. So recall that to multiply matrices, we must determine first whether they can be multiplied by watching their orders. This is a 2 by 2 matrix multiplied by a 2 by 1 matrix. Their inner numbers are the same, which means they can be multiplied, and their outer numbers tell us what the answer matrix would be, a 2 by 1 matrix. So let's work it out.
We multiply the first by the first, which is 1 multiplied by 23, which is 23, plus the second multiplied by the second, which is negative 3 multiplied by 21. That is negative 63. 23 plus negative 63 is 23 minus 63, which is equal to negative 40.
Let's do the second row now. Negative 4 multiplied by 23, which is negative 92, plus 2 multiplied by 21, which is 42, gives us negative 92 plus 42, which is equal to negative 50. We're almost at the end. We're almost there.
So now we have x is equal to 1 over negative 10 multiplied by the matrix. That gives us negative 40 over negative 10 and negative 50 over negative 10. These can be simplified to 4 and 5 as the negative signs cancel each other out.
Remember, that was just scalar multiplication there, right? And there we have it. Matrix X, which is a matrix which contains our variables x and y, is equal to the resultant matrix containing the numbers 4 and 5. Variable x therefore is equal to 4 and variable y is equal to 5.
And that's it for the topic of matrices. We did it.
Yes, we know that was plenty. It was a lot. But rewatch the videos as many times as you need to, and be sure to practice. Practice. As you say, practice, right? With the questions that can be found in the links in our description. That way, the principles we learn will become second nature to you.
Thank you for watching OpenSec Math. This episode has been brought to you by BP, produced by the 2 Cents Movement with the help of these lovely people.
Be sure to like and subscribe to our channel.